Okay, we'll start in a minute or two. So you can go ahead and sign in. So if you're online, can you hear? Hey, it's 8 o'clock. Go ahead and get started. Okay, so yesterday we looked at the slope-intercept form. So here's this statement about the slope-intercept form. The equation of a non-vertical line in the xy plane can be written in the form y equals mx plus b, where m is the slope of the line and the ordered pair 0b is the y-intercept. Okay, so we will rewrite the following linear equations so that they are in slope-intercept form. Okay, so all we have to do is solve for y, starting with 2x minus 3y equals negative 6. Let's start by subtracting 2x from both sides, and we'll get negative 3y equals negative 2x minus 6. And then divide every term on both sides by negative 3. So for this next step, I'll go into a little more detail than is necessary. Divide negative 3y by negative 3. And on the right-hand side, negative 2x divided by negative 3, and then minus 6 divided by negative 3. Negative 3y divided by negative 3 is y, 1y. Negative 2x divided by negative 3 is positive 2/3 x. And then minus 6 divided by negative 3 is negative 2. And we'll simplify it a little more because subtracting negative 2 is equivalent to adding 2. So we get y equals 2/3 x plus 2. Hey, so what's the slope of the line? Slope of that y equals 2/3 x plus 2. Yeah, the slope is 2/3. The coefficient of x is 2/3, so the slope is 2/3. And what else do we know? Yeah, the y-intercept is an ordered pair. So the y-intercept is the ordered pair 0 for x and positive 2 for y. So that's something to remember about a y-intercept. Since the y-intercept is a point in the xy plane, it is associated with an ordered pair, 0 for x and 2 for y. Okay, the next equation, 2x plus 8y equals 16. So when we solve this one for y, first subtract 2x from both sides, and we'll get 8y equals negative 2x plus 16. And then divide every term on both sides by 8. So when you divide the left-hand side by 8, 8y divided by 8 is y. Negative 2x divided by 8 is negative 2 over 8x, but reduce the negative 2 over 8 to negative 1/4. So we write negative 1/4 x. And then 16 divided by 8 is 2, so we get plus 2. Okay, so the slope of this line is negative 1/4. And the y-intercept is the same as the previous one, but that's okay. The y-intercept is the ordered pair 0, 2. Okay, if you're watching on YouTube, go ahead and sign in. I see one person who signed in. So something, I don't know if something's wrong or what, but. Go ahead and sign in for attendance. Okay, here's our next definition. Two lines are parallel if they have the same slope but different y-intercepts. One thing nice about equations that are in slope-intercept form is we can tell by looking what the slopes of the lines are. So the slope of the line on the left, y equals 2x plus 1, is 2. So for this line, the slope is 2. And the y-intercept is 0, 1. The other line, y equals 2x plus 3, the slope of that line is 2. And the y-intercept is the ordered pair 0, 3. Okay, so why don't we sketch a little graph here of those two lines. So this line, the one that has the y-intercept of 0, 1, so 0, 1 is a point on the line. And then if we use the slope 2, think of the slope as 2 over 1. Then from this point, we have a rise of 2 and a run of 1. So we have this line. Well, the other line, the other line has a y-intercept of 0, 3. So 0, 3, this one, this point. And the slope is also 2. So we can think of 2 as positive 2 over 1. So we get this point on the line. Or you can think of it as negative 2 over negative 1. And we get those points. Okay, so the idea with parallel lines is that they never intersect. They run alongside each other and they never touch. Okay, the next one, two non-vertical lines are perpendicular if their slopes are negative reciprocals. So here's an example of two lines that are perpendicular. On the left, y equals negative 3/2 x plus 5/2. The slope of this line is negative 3/2. And the other line, y equals 2/3 x plus 4/3. The slope of this line is 2/3. So the two slopes are negative reciprocals. So if we didn't know that the negative reciprocal of negative 3/2 is 2/3, then this is how you would do it. You could say the negative reciprocal of negative 3/2 is the negative, and then write the reciprocal of negative 3/2. So the reciprocal of negative 3/2 is negative 2/3. And the negative of negative 2/3 is positive 2/3. So with a little practice, it will become obvious how to find the negative reciprocal of a non-zero number. Okay, but if we want to do the same thing with the other slope, the negative reciprocal of 2/3, well, just write the negative of the reciprocal of 2/3 is 3/2. So negative 3/2 is the negative reciprocal. So that matches what we've said before. Okay, on the next page, we will determine if the pairs of lines are parallel, perpendicular, or neither. So this is our first pair of lines, 5x plus 4y equals 20, and 4x minus 5y equals 20. So how should we go about finding or determining if the lines are parallel, perpendicular, or neither? We can rewrite each of those two equations so that they are in slope-intercept form, the y equals mx plus b form. And then all we would have to do is look at the coefficient of x in each of the two equations, because that will be the slope. So let's rewrite each of those two equations so that each one is in y equals mx plus b form. Okay, so 5x plus 4y equals 20 to solve for y. First subtract 5x from both sides. So we get 4y equals negative 5x plus 20. Then divide every term on both sides by 4. 4y divided by 4 is y. Negative 5x divided by 4 is negative 5/4 x. And then 20 divided by 4 is positive 5. Okay, so the slope of this line on the left is negative 5/4. Okay, now we'll solve the second equation for y. So first subtract 4x from both sides, and we get negative 5y equals negative 4x plus 20. Divide every term on both sides by negative 5. Negative 5y divided by negative 5y is, negative 5y divided by negative 5 is y, 1y. Negative 4x divided by negative 5 is positive 4/5 x. And 20 divided by negative 5 is negative 4, so we write minus 4. The slope of this line is positive 4/5. So what can we say about the two lines? Yeah, the two lines are perpendicular because the slopes are negative reciprocals of each other. You see that? So these two lines are perpendicular. Well, I should graph two lines that are perpendicular at some point. But two lines that are perpendicular I won't graph these two lines, I'll just show you what two lines that are perpendicular look like. So if you have one line that looks like this, then a line that's perpendicular to it would look something like that. They form a right angle when they intersect. Another example of perpendicular lines are the x-axis and the y-axis. But the slope of the y-axis is undefined because it's a vertical line. So this is what perpendicular lines look like when they're, this is just one example, perpendicular lines. Okay, the next pair of lines, 3x minus 4y equals negative 1, and negative 6x plus 8y equals negative 6. So we want to determine if those two lines are parallel, perpendicular, or neither. So we can rewrite each equation so that each one is in slope-intercept form. So in other words, solve for y. So to solve this for y, subtract 3x from both sides. So we get negative 4y equals negative 3x minus 1. Then divide every term on both sides by negative 4. Negative 4y divided by negative 4 is 1y, or just y. Negative 3x divided by negative 4 is positive 3/4 x. And negative 1 divided by negative 4 is positive 1/4. Okay, so the slope of the line on the left is 3/4. Now let's rewrite the other equation so that it's in slope-intercept form. So this time add 6x to both sides. We get 8y equals 6x minus 6. Then divide both sides by 8. 8y divided by 8 is y, 1y. 6x divided by 8 is 6 over 8x, but then reduce the fraction 6 over 8 to 3 over 4, so 3 over 4x. And then minus 6 over 8 is minus 3/4. Okay, so the slope of the second line is 3/4. The two lines have the same slope, but different y-intercepts. So that means the two lines are parallel lines. Okay, another example, 2x plus 5y equals 10 and 3x minus 4y equals 12. With some practice, you can almost tell by looking, even when the equations are in standard form, whether they're parallel, perpendicular, or neither. But rather than just guessing, we can solve each of the two equations for y. For 2x plus 5y equals 10, start by subtracting 2x from both sides. So we get 5y equals negative 2x plus 10. Then divide every term on both sides by 5. 5y divided by 5 is y. Negative 2x divided by 5 is negative 2/5 x. And then positive 10 divided by 5 is 2. Okay, so the slope of this line is negative 2/5. You solve the other line, the other equation for y. 3x minus 4y equals 12. Subtract 3x from both sides to start with, so we get negative 4y equals negative 3x plus 12. Divide every term on both sides by negative 4. Negative 4y divided by negative 4 is y, 1y. Negative 3x divided by negative 4 is positive 3/4 x. 12 divided by negative 4 is negative 3, so we write minus 3. And the slope of this line is positive 3/4. Okay, so what do we say? Are the lines parallel, perpendicular, or neither? They are neither because, well, the slopes aren't the same, so they're not parallel. And the slopes are not negative reciprocals. So we say neither parallel nor perpendicular. Hey, before doing the next example, I'll give you a question. What can you say about two lines in the XY plane that do not have the same slope? Well, I suppose there are a number of things, but there's something in particular that I'm thinking of, and if you can't read my mind, it's kind of hard to know exactly what I'm getting at. But this is something to keep in mind. Two lines, by which I mean straight lines. So two lines with different slopes will intersect at exactly one point. At exactly one point in the XY plane. Okay, so that concept will be useful to remember. And it makes sense. Okay, the next problem. This says find the slope-intercept equation of the line that passes through the point 0, -2, and that is perpendicular to the line y equals 2/3 x plus 1. Okay, so this equation is given in slope-intercept form. So I'll refer to this as the given line. So the slope of the given line is 2/3. Slope of the given line is, all right, m equals 2/3. So any line that is perpendicular to that line will have a slope of what? Yeah, -3/2. So any line perpendicular to it, any line that's perpendicular, there are infinitely many lines with the same slope. So any line perpendicular to the given line has a slope of m equals -3/2. That's the negative reciprocal of 2/3. Okay, so we have half the information. We want to find the slope-intercept equation of this perpendicular line. So we can at least write y equals -3/2 x plus b. All we have to do now is find b. So do you know what the number b is? Well, remember that b is the y coordinate of the y-intercept. But the point that we're given that the perpendicular line passes through is the y-intercept, 0, -2, right? When x is 0, the y coordinate is -2. So 0, -2 is the y-intercept of the perpendicular line. You see that? So all we have to do is replace b with -2. because 0, -2 is the y-intercept of this line. So y equals -3/2 x minus 2, since this line passes through the point 0, -2. Okay, what's an alternative if you don't automatically recognize that the given point that the perpendicular line passes through is the y-intercept? What can you do? Okay, well, we have this much information so far. We also know that the graph of this line passes through the point 0 for x and -2 for y. So we can, in this equation, we can replace the variable y with the y-coordinate, and we can also replace the x variable with the x-coordinate. So replace y with -2, replace x with 0, so we get -2 equals 3/2 times 0 plus b. But -3/2 times 0 is 0, so we get -2 equals b. And that is exactly what we already knew. If we replace b with -2, then we write the equation this way: y equals -3/2 x minus 2. Do you see how that works? So it's nice if you are given the y-intercept, and if you recognize it as the y-intercept, you'll automatically know that the value b is -2. But even if you don't, for a linear equation in the form y equals mx plus b, any point whose ordered pair is given has to satisfy the conditions of the equation. That just simply means that if you replace the variable x with the x-coordinate of a point and replace the variable y with the y-coordinate of the point that's on the line, then you have to get an equation that is true. Okay, let's move on to the next page. So here are some applications, so-called applications. Okay, so this one says in the linear equation, C equals 28 times G plus 450. C represents the cost in dollars to accommodate G, capital G guests. So this is a cost function for a hotel or something, or a motel, or a resort or something. So capital C represents cost in dollars. Capital G represents the number of guests. And so the cost, we'll just suppose this is like a daily cost. So the cost to accommodate G guests is 28 times G plus $450. Okay, what's the slope of the line? Yeah, 28 is the slope, but what are the units? So if we were given ordered pairs, okay, this doesn't look like y equals mx plus b, but it has the same form as y equals mx plus b, just different variables. So if this were y equals mx plus b, And then if you remember the slope formula, y2 minus y1 in the numerator, x2 minus x1 in the denominator. Well, if you were given ordered pairs, what would they look like? Which variable would be on the left and which variable would be on the right?
0 on the left, 450 on the right.
Yeah, instead of y, we have c, so our ordered pairs aren't of the form xy, but instead of y, we have c. So we have c on the right, and instead of x, we have g, so g is the left coordinate, right? So if we had two ordered pairs of the form G1, C1, and G2, C2, then how would we find the slope of the line that passes through those 2 points? Okay, instead of x1, y1, we have g1, c1, and instead of x2, y2, we have g2, c2. So we'll just mimic the slope formula in the variables x and y. So what should I write in the numerator, and then what should I write in the denominator?
C2 minus C1 in the numerator.
Yeah, in the numerator I can write c2 minus c1 instead of y2 minus y1. And in the denominator, g2 minus g1. Okay, and what are the units of the c values? The units for c are dollars, right? Capital C represents the cost in dollars. So the unit for the numerator is dollars. And what's the unit for G? Yeah, G is the number of guests. So we could say that the units for the slope are dollars per guest. So the units for M, the slope, you can think of that as dollars per guest. Do you see how that works? So we know what the slope is, 28G, or sorry, the slope is just 28. So $28 per guest is the slope. So how would we interpret that? We could say that for each additional guest, in other words, if we increase the number of guests by 1, we're going to increase the cost by $28. So that's our interpretation. So I'll label it as interpretation of the slope. Just one way to think of it. If the number of guests increases by 1, I'll just say increase guests by 1 will increase the cost by $28. Does that seem to make sense? Right, because each guest, $28 per guest. G is the total number of guests. Okay, let's look at the next example. In the linear equation, capital P equals 0.575 capital M plus 42. Capital P represents the amount a driver is paid each day for driving M miles. Okay, we don't have y equals mx plus b. We have P equals lowercase m times capital M plus 42. So the ordered pairs, instead of x, y, they would be capital M, comma, capital P. So if we had two ordered pairs, say M1, P1, and M2, P2, then our slope, we would write it as P2 minus P1 instead of Y2 minus Y1 over capital M sub 2 minus capital M sub 1. So what are the units of capital P? Yeah, dollars. It's the amount a driver is paid. We assume it's in dollars, hopefully not pennies. So dollars are the units for capital P. What are the units for capital M? Miles. Oops, miles. Okay, so in this equation, the slope is 0.575 dollars per mile. So the slope is 0.575 dollars per mile. Okay, so how do we interpret that? We can say that for each additional mile that the driver drives, he will be paid an additional 57.5 cents, right? $0.57. I don't know if that's a good rate for driving or not, but you see how that works? So our interpretation for each additional mile driven, for each additional mile driven, the driver will be paid an additional $0.575. But $0.575 is just 57.5 cents, right? So the driver will be paid an additional 57.5 cents. A little over half a dollar for each additional mile. Hey, let's look at the next problem. A caterer charges $12 per dinner plus a $30 service charge for catering. If capital C is the total catering charges in dollars, and D is the number of dinners prepared, then we can write this as a linear equation. capital C equals 12 times D plus 30. Okay, so suppose for one event, the caterer prepares 8 dinners. So how much will the total catering charges be? So in the equation, lowercase d represents the number of dinners. So we just say when the number of dinners is 8, the total catering charges will be 12 times 8 plus 30. 12 times 8 is 96, so 96 plus 30 equals 126. So this is just our arithmetic without units, and then if we want to summarize the results, we would just say the catering charges are $126 for preparing 8 dinners. Okay, so that's all for that part. Interpret the slope of the same line. So what are the units of the slope? If we were to write ordered pairs, so you can always think back to the y equals mx plus b. If we have y equals mx plus b, the ordered pairs have the form x comma y in parentheses. So the ordered pairs, instead of x, we're using d. Instead of y, we're using capital C. So if we have two ordered pairs, D2, C2, and D1, C1, or vice versa, then our slope is C2 minus C1 divided by D2 minus D1. The units for capital C are dollars. And the unit for lowercase d is dinners. So dollars per dinner is the slope. Okay, so our slope is $12 per dinner. $12 per dinner. So in one sentence, how would you interpret that?
Every one dinner that's made, they receive $12 for it.
Yeah, for each additional dinner, the catering charges would increase by $12, right? So for each additional dinner, if you have somebody that signs up late, but the caterer is willing to prepare an additional dinner, for each additional dinner, the catering charges increase by $12. Okay, so I guess that's all for today. Tomorrow we'll be in section 3.3.